Hey everybody, Mr. Gajewski here, and today we're going to talk about solving one-step inequalities and the properties of solving inequalities. So let's go ahead and let's look at a few examples here. We're going to look at our first one. X plus 9 is less than 15. So just like solving an equation, we need to use inverse order of operations, and we need to do the same operation to both sides to keep the inequality balanced. So the opposite of addition is subtraction. We're going to go ahead and subtract 9. We get x is less than 6. And a way we can check this is we can pick any number less than 6. Let's go with 3. Let's plug that in for x. Well, is 3 plus 9 less than 15? Is 12 less than 15? Yeah. We can pick any number less than 6, and we should get a true statement. So I'm going to go ahead and circle that up. How about this one? D minus 3 is greater than negative 6. I'm going to undo subtraction, so let's go ahead and let's add. We get D is greater than negative 3. Very similar to solving equations. How about 3x is greater than negative 27? Let's go ahead and do the opposite of multiplying 3. We're going to divide by 3. We get x is greater than negative 9. Let's change it up a little bit here. So we have 2/3 r is less than 6. So we want to divide by 2/3. Well, if you remember, dividing by a fraction is the same as multiplying by the reciprocal. So let's multiply both sides by the reciprocal of 2/3. The reciprocal of 2/3, that's 3/2. And when I do that, I'm going to get r is less than, well, what is 6 times 3/2? Well, 6 times 3 is going to give me 18. 1 times 2 gives me 2. Let's go ahead and let's simplify that. 18/2 is 9, so r is less than 9. Go ahead and circle that one. We're going to go ahead and we're going to look at some different examples. So here's really the main difference between inequalities and equations. So what happens when we multiply or divide by a negative number? Well, in this case, we're still going to follow the inverse order of operations. So I need to get rid of this negative 8. I'm going to go ahead and divide by negative 8. That'll give me x on the left-hand side. But here's the kicker. This greater than sign is going to get flipped into a less than sign. So x is less than negative 9. Then we go ahead and circle that up. And we can try this out if we're not sure. So let's pick a number less than negative 9 to see if this works, if this makes sense. How about negative 10? All right, so negative 8 times a negative 10 greater than 72. Well, negative 8 times negative 10 is going to give me positive 80. Is positive 80 greater than 72? Indeed, it is. Let's go ahead and let's try our other example here. So negative 3 is less than or equal to x over negative 5. Well, we need to undo this division, so let's go ahead and let's multiply both sides by negative 5. Negative 5, times negative 3 is going to give me positive 15. We're going to go ahead and flip the sign. That'll give me x, because the negative 5s will cancel out. Now with inequalities, if I'm going to read this, I would read this as 15 is greater than or equal to x. But it's going to be easier for me to think about the solutions to this inequality if I go ahead and write the x on the left-hand side, which means I'm also going to have to flip my symbol of relation. So the greater than or equal to becomes a less than or equal to again. And what is x less than or equal to? Is less than or equal to 15. Go ahead and circle that up. So there are a few brief examples of solving inequalities. So remember, if we're adding or subtracting, multiplying or dividing by a positive number, it is just like solving an equation. And the only main difference is multiplying or dividing by a negative number, in which case we need to flip the symbol of relation. That is it for solving one-step inequalities. I hope that helps, and I will see you next time.